Welcome to my channel SK Vidyayan Physics classes. Now I shall discuss some important questions on electrostatics. First question is, the material filled between the plates of a parallel plate capacitor has resistivity 200 ohm meter. The value of capacitance of capacitor is 2 picofarad. If a potential difference of 40 volt is applied across the plates of capacitor, the value of leakage current flowing out of capacitor is, choices are 0.9 milliampere, 9 milliampere, 9 microampere and 0.9 microampere. Relative permittivity, that is dielectric constant of the material, is given 50. So how to solve this problem? Now a capacitance filled with a dielectric medium and it has a resistivity of rho equal to 200 ohm meter. Now it is charged to a potential difference of 40 volt and the capacitance is 2 picofarad. Relative permittivity, that is dielectric constant, is 50. Now it is a fully charged capacitor and the expression for charge in this case is charge at any instant equal to maximum charge e to the power minus t upon RC or CR. RC is the time constant, Q0 is the maximum charge. Now, because of this charge on the plates, it will tend to discharge. How it will discharge? Discharge through a resistor, and during the process of discharging, the charge on the plates of capacitor changes by the formula Qt, Q0, this one. Now, as the charge changes, because of the polarization, the surface charges also changes on the surface of the dielectric. And as we know that polarized charge or induced charge, say Qp equal to minus Q 1 minus 1 by K. K is dielectric constant or epsilon r. So because of the variation of this charge on the plates of capacitor in the process of discharging of the capacitor, this polarized charge will change and this will produce a current, leakage current, which is same as dq by dt. So let us find out, differentiate this expression dq by dt, or you write it is a capital Q. dq by dt is minus q0 rc e to the power minus t rc. At time t equal 0, this is 1 and current equal to I0, negative sign, so the direction is opposite to the charging current. Now this is the discharging current, I equal to I0, I0 is the maximum current, which is equal to Q0 by RC. So how to find out? Now this is the leakage current, I0, maximum charge Q0 R into C. Q0 is the maximum charge, that is C into potential difference V, R, C got cancelled, V by R. Resistance of the medium in between the plates of capacitor is rho L by A. Now, L means the separation between the two plates, that is D. So better I write it is equal to D by A. A is the area of each plate, that is We know capacitance equal to epsilon 0, epsilon r, that is into area by separation, or D by A equal to epsilon 0, epsilon r by C. So I0 leakage current equal to potential difference B, R equal rho into D by A. Rho is given, D by A is epsilon 0, epsilon R divided by C. C goes to the numerator. Now putting the values of B is 40 volt, C is 2 picofarad, 2 into 10 to the power minus 12 farad, and resistivity 200 ohm meter, epsilon 0 8.85 10 to the power minus 12 SI unit into epsilon r 50. So on solving this, 10 to the power minus 2 got cancelled. It is 8 divided by 8.85 into 10 to the power 3, that is 80 by 88.5 10 to the power minus 3. It is nearly 0.9 milliampere. So the answer is first choice 0.9 milliampere. This is a good question. Now second question is, this figure shows a part of complete circuit. At time t equal 0, charge on the capacitor as a function of time is Q equal to 3 into 1 minus e to the power minus t coulomb. It is asked, at time t equal to 0, mark the correct statements. What is the circuit here? This point is at 20 volt. This is a capacitor of capacitance 1 farad. Even though 1 farad capacitor is not seen, it is very large. For simplicity in answer, it is given 1 farad. This is a resistor of 1 ohm, and now here this point is at 20 volt, and source of EMF has potential difference 2 volt. Here is a resistor of 1 ohm. This point is P. This is a resistor R. So again I am telling, this point is at 20 volt. A capacitor of capacitance 1 farad. A resistor 1 ohm. This point is P. This point is at 20 volt potential. A battery of EMF 2 volt, a resistor of 1 ohm, and this is grounded. Let us assume that the current through this branch is I1, the current through this branch is I2, and let us see. Now DC current cannot pass through this capacitor, but it is given charge at any instant equal to 3 into 1 minus e to the power minus t. And you want to find out the correct statements at a time t equal to 0. Now, at a time t equal to 0, the charge on the capacitor is 3 coulomb. At time t equal to 0, this is 1, charge on the capacitor is 0. So initially this capacitor is not charged, but when we connect the circuit charging current flows. So how to find out the charging current? By differentiating Q, I equal to 3, derivative of 1, 0, so this is e to the power minus t. Now at time t equals 0, this I equal to 3 ampere. So at a time t equals 0, the charging current is 3 ampere, and this 3 ampere current, when flows through this resistor of 1 ohm, the potential difference across, say, 1 ohm resistor is equal to 3 volt. Now see, this is at 20 volt. If you use Kirchhoff's law, say, the fall of potential 20 volt at time t equals 0, there is no charge on the capacitor, so no potential difference. So 20 volt minus 3 volt is 17 volt. So potential at point P is 17 volts. Now come to this branch, that is, this point is at 20 volt. The source of EMF has potential 2 volt, and this point has potential 17 volt. Now if you analyze, if you apply Kirchhoff's law, the sum of change of potential 0, so this is 20 volt minus 2 volt, R is 1 ohm into current, say, I2 ampere, is equal to 17 volt, and this is equal to I2 equal to 20 volt minus 2 volt minus 17 volt is 1. So it is 1 ampere. Now I2 is 1 ampere and I1 is 3 ampere. I1 is 3 ampere. So current I is equal to 4 ampere. Now this is grounded, so this potential 0. Now this is 17 volt, so the potential across the resistor is R is 17 volt. Now so R into 4 ampere, that is R ohm into 4 ampere is equal to 17 volt. So resistance equal to 17 volt by 4 ampere. This is equal to 4.25 ohm. Now first I1 is 3 ampere, it is correct. This was our I1, correct. And I is 4 ampere, this is I2 plus I1. I1 3 ampere, I2 1 ampere, so I is 4 ampere. Now this is also correct. Potential of this point P is 17 volt, this is correct. And resistance is 4.25 ohm, this is also correct. So all choices are correct. Now this is a very conceptual question, and I hope this discussion will benefit the students. Thank you.